Assalamu alaikum.
वालेकुम अस्सलाम।
वालेकुम अस्सलाम।
हाँ जी, लास्ट टाइम हमने ट्रांसफार्मर्स शुरू किया था और ट्रांसफार्मर मैंने कहा था कि इट इज एन इलेक्ट्रिकल apparatus that is used to convert low alternating voltage to high alternating voltage or vice versa. What we have seen that there are the two types of transformers. One is called the step up transformer and other is called the step down transformer.
सर हम लोगों ने
और
ये पढ़
किसी भी
लिया था।
ट्रांसफार्मर का जो बेसिक प्रिंसिपल है दैट बेस्ड अपॉन द वर्किंग प्रिंसिपल जो दैट बेस्ड अपॉन द मैग्नेटिक इंडक्शन। इट मीन कि अगर आप एक कॉइल के अंदर लेट वी से कि वी चेंज द करंट इन द प्राइमरी कॉइल देन EMF is induced in the secondary coil. So what you have in the case of the step-up transformer, we say that the low voltage or high AC current is converted into the high voltage and the low AC current. In this type of the transformer, the number of turns in the primary will be small as compared to the number of turns in the secondary. In other words, you can say that the NS is greater than NP. The other transformer is called the step-down transformer. In the step-down transformer, we convert the high primary voltage to the low secondary voltage. In other words, you can say that in this type of transformer, the low current is converted into the high current. So that is the step-down transformer. And in the case of the step-down transformer, the number of the primary winding is greater than the number of turns in the secondary winding. So we have this one. Then we have the different types of transformers also depending upon the core. We have the air core transformer. In the air core transformer, both primary and the secondary winding are wounding on the some non-magnetizing material. So the linkage between the primary coil and the secondary coil is through the air. If you compare the air core transformer with the iron core transformer, you can say that the reluctance offered by the generated flux is high in the air medium, क्योंकि इसमें रिलक्टेंस जो है वो ज्यादा होगी, जबकि एयर आयरन कोर में रिलक्टेंस जो है वो क्या है वो कम होगी. So in this way you can say that in the case of the air core transformer, the eddy currents are completely eliminated. So this is the air core transformer. This is the situation. We have the two coils. One is the primary coil. What is meant by the primary coil? Primary coil means that coil in which across which the alternating source is applied, whereas the secondary coil is the coil in which the induced voltage is produced. So मैंने आपको ये भी बताया था कि we cannot apply the DC source here because we have no transformer which change the DC. Then we have the iron core transformer. In the iron core transformer, both the primary and secondary winding are wounded on a multiple iron plates, bunch which provides a perfect linkage path to the generated flux. It means अगर आपके पास you have the number of the iron strips हों और उन iron strips पे let I say कि we have hollow square strips और अगर आप उन hollow square strips पर winding करेंगे तो then what you see that कि iron will link, उसका जो फ्लक्स होगा वो कंप्लीटली लिंकेज पाथ पर प्रोवाइड करेगा. It offers less reluctance to the linkage flux due to the conductive and the magnetic properties of the iron. These transformers are widely used in which the efficiency is high compared to the air core transformer. This is a iron core. Here what you have, here we have the number of the iron strips which are in the form of the square, and on the left hand side the one coil is wounded, on the other side the other coil is wounded. So it means now we have the auto transformers. In the case of the standard transformer, we have the primary and the secondary winding placed in the two different directions. और उसमें आप देखेंगे कि आम ट्रांसफार्मर्स के अंदर आपकी एक प्राइमरी कॉइल है और एक सेकेंडरी कॉइल है. उन दोनों को आप डिफरेंट डायरेक्शन में वाइंड करते हैं. मीन कि अगर आप एक कॉइल जो है वो क्लॉकवाइज वाइंड कर रहे हैं तो दूसरी कॉइल को आप एंटी क्लॉकवाइज वाइंड करेंगे. बट इन द केस ऑफ द ऑटो ट्रांसफार्मर वाइंडिंग, the primary and the secondary winding are connected to each other in series. यानी कि इसका मतलब ये हुआ कि ऑर्डिनरी ट्रांसफार्मर्स के अंदर both primary coil and the secondary coil, they are isolated from each other. But here in the case of the auto transformer, both coil, primary and the secondary, they are connected serially. तो अगर आप इन दोनों को serially connect करेंगे तो then they will magnetize physically and magnetize as shown. Let me say here that this is auto transformer. Here, this is a primary coil across which the voltage is applied. Here we have the two coils that are connected serially in the same direction. दोनों को आपने एक ही डायरेक्शन में serially bound करना है. It means कि this coil is rotated in the anti-clockwise direction. Sorry, this is connected in the clockwise direction. So what you see here, according to the voltage divider rule, what you have seen, we have seen that कि जब आप किसी भी दो कॉइल्स या दो रेजिस्टर में से करंट फ्लो करता है तो और अगर सीरियली कनेक्टेड हैं तो उनके अक्रॉस एक वोल्टेज डिवाइड होगा. तो here what you see, here we see that let I is the current supplied. Let me say here, this is the primary coil and this is the secondary coil. In the primary coil, the current is, let me say, this is I1, and in the अगर टोटल करंट I है तो इसमें I1 इधर जाएगा and the I2 current go to the load. The remaining current, that will be the I2 minus I1. So we see that here will be a induced voltage, that is the V2 across the load. So आम तौर पर ऑटो ट्रांसफार्मर्स के अंदर आप मल्टीपल लोड्स जो हैं वो अटेन कर सकते हैं. You have a multiple loads here, and you can find the voltage by using the voltage divider rules only. So what will be the voltage divider? मैंने आपको बताया था कि अगर आपको कहा जाए कि determine the voltage V2, so what you have the formula, you have the formula that is the XL2 over XL1 plus XL2 into V. What is the XL1? XL1 is the inductive reactance across the primary coil, and XL2 is the inductive reactance across the secondary coil. जिस तरह वोल्टेज डिवाइडर रूल अप्लाई करते हो, यहाँ भी उसी तरह आपने वोल्टेज डिवाइडर रूल अप्लाई करना है. मतलब अगर दो रेजिस्टेंसेस R1 एंड R2 they are connected in series, और आपको ये कहा जाए कि determine the voltage across R2, तो आप क्या लिखते हो? You simply write down there कि V2 is equal to R2 over R1 plus R2 into V. And a single common coil which form both primary and the secondary, in which the voltage is varied according to the position of the secondary tapping on the body of the coil. अगर आप ये different points पे इसको प्लेस, मतलब अगर point C आपका different locations पर जाएगा तो then the voltage will be vary. अगर आपका ये point C at the center होगा तो then this voltage is equally divided across V1 and V2. लेकिन अगर ये let we say कि this point C moves towards B, अगर ये point C B की तरफ move करेगा तो V2 will be smaller as compared to the V1. So in this case you can use the now we see the transformer working. How the transformer works. The main principle of operation of the transformer is the mutual induction between the two circuits or between the two coils, which is linked by the common magnetic flux. As in the case of the iron core transformer, what you have seen. In the case of the iron core transformer, we have seen that the two coils, the primary coil and the secondary coil, that is wounded on the same material. So it means कि अगर आप प्राइमरी कॉइल के अंदर EMF को चेंज करते हो तो then उसका फ्लक्स जो है, प्राइमरी कॉइल का फ्लक्स जो है, that will directly link with the secondary coil. So you can say that कि secondary coil के अंदर आपकी जो induced EMF generate करेगी, that will be directly proportional to the rate of change of the primary current. प्राइमरी करंट में आप जितनी ज्यादा चेंज करेंगे तो उसके क्रॉसपॉन्ड आपका सेकेंडरी कॉइल के अंदर उतना ही ज्यादा EMF इंड्यूस करेगा. So as you see that our basic transformer consists of two coils and are electrically separate and inductive, but are magnetically linked through a path of the reluctance. मैंने आपको path of reluctance भी बताया था कि reluctance होती क्या है. ठीक है, वो एक्चुअली दैट इज अ फ्लक्स है जो फ्लक्स लिंक करता है. द वर्किंग प्रिंसिपल ऑफ द ट्रांसफार्मर कैन बी अंडरस्टूड फ्रॉम द फिग. हियर वी हैव अ ट्रांसफार्मर. देयर आर द टू कॉइल्स, one is the primary and other is the what they show, the above fig show that the electrical transformer has the primary and the secondary winding. The core is laminated or joined from the strip. The core lamination are joined in the form of strips in between the strips, you can see that there are some narrow gaps right through the cross section of the core में से आप खुद देख रहे हैं कि इसके अंदर कोर्स के दरमियान जो है एक नैरो गैप है. These suggested points are said to be imbricated. Both the coils have high mutual induction. अमूमन हम क्या करते हैं कि जो हमारी जो स्ट्रिप्स हैं उनको हम लैमिनेट किया करते हैं. These strips are laminated by the varnish or some other painting material paints, and then this is dipped into the some insulating material. Both coils have a mutual electromotive force is induced in the transformer from the alternating flux that is set up by the laminated core due to the coil that is connected. So most of the alternating flux develop. ये सारी चीजें आपने FSC में देखी होंगी कि what is the basic principle there. The basic principle is there is the Faraday's law of electromagnetic induction. और Faraday law of electromagnetic induction आपको ये बताता है कि किसी भी कॉइल के अंदर अगर आप EMF को चेंज करोगे, there would be a change in the magnetic flux, और उस magnetic flux की वजह से आपकी EMF जो है वो सेकंड कॉइल के अंदर इंड्यूस करती है. This is an equation that EMF is equal to M di by dt, where M stands for the coefficient of mutual induction. If the second coil circuit is closed, the current flow in it, and thus electrical energy is transformed magnetically from first to the second coil. The alternating current supply is given by the first coil, and hence it is called the primary winding, and energy is drawn out from the second coil. So due to this reason it is called the secondary winding. यहाँ तक last time हमने देख लिया था. Next we have the ideal power equation of the transformer. How we can define the electrical power? The electrical power is defined as the product of current and voltage. So here we have two currents. One is called the primary current and other is called the secondary current. So you can write the IP into VP is equal to the IS into the VS. So then you can write here, this is a transformer equation. That is the ratio of the primary to the secondary voltage will be equal to what? That will be equal to the ratio of the secondary current to the primary current, and it can also be written as the ratio of the primary turn to the secondary turns. So in this case, what we have seen, you can write here, the VP is equal to the NP over NS into VS. अब आप खुद देख लें कि अगर आपकी नंबर ऑफ टर्न्स इन द प्राइमरी स्मॉल हों और सेकेंडरी में ज्यादा हों तो देन दैट इज कॉल्ड स्टेप अप ट्रांसफार्मर, और अगर आपकी नंबर ऑफ टर्न्स प्राइमरी में ज्यादा हैं और सेकेंडरी में कम है तो दैट इज नोन एज स्टेप डाउन ट्रांसफार्मर. If the secondary coil is attached to the load that allows current to the flow, the electrical power is transmitted from the primary circuit to the secondary circuit. Ideally, the transformer is perfectly efficient. All the incoming energy is transformed from the primary circuit to the secondary circuit. In this condition, if this condition is met, the ideal transformer, the input electrical power must be equal to the output electrical power. So, in other situation, you can say that in the case of the ideal transformer, if the number of turns in the secondary is same as the number of turns in the primary, then what you see there, you will see there that Vs is equal to the Vp. Any question you have?
No, sir.
Any question?
सर इस आइडियल इक्वेशन में हमने जैसे लिखा है Vp डिवाइडेड बाय Vs इक्वल्स टू Is डिवाइडेड बाय Ip, तो अगर हम इसको लिखते हैं Vs डिवाइडेड बाय Vp इक्वल्स टू Ip डिवाइडेड बाय Is तो कोई फर्क तो नहीं होगा?
This is our equation that the P incoming is equal to the P outgoing. The incoming is written as IPVP and the outgoing is written as the ISVS. अगर आप इन दोनों equations को equal करें तो then you can find the ideal transformer equation, that is the Vs over Vp is equal to the Ns over Np, or this is also equal to Ip over Is. This is the ideal equation. Here we have a simple example.
सर अगर हम Vs over Vp की जगह
जी
सर मैं कह रही हूँ अगर हम Vs over Vp की जगह Is over Ip लिखते हैं और जो
आप
करंट
दोनों
है
इक्वेशन जो है वो यूज
चेंज
कर
कर दें
सकते
तो कोई
हैं डिपेंडिंग कि आपको प्रॉब्लम के अंदर क्या चीज गिवन है. अगर आपको करंट्स गिवन है तो देन यू कैन राइट Vs over Vp over Vs is equal to Is over Ip. और अगर आपको नंबर ऑफ टर्न्स गिवन है तो उस सूरत में भी आप देख सकते हैं. मसलन दिस इज एग्जांपल. A transformer has 400 turns on the primary. It means the NP is the 400 and NS is the 1200. So it means this is a step-up transformer. If 120 volt of the AC is applied across the primary, it means if VP is the 120, what is the secondary induced voltage? So you can find this one. So you can determine the secondary voltage here. The ideal transformer, in the case of the ideal transformer, what you have seen, if the voltage is increased, then the current is decreased by the same factor. अगर आप वोल्टेज को इंक्रीज करेंगे तो दूसरे कॉइल में आपका करंट उसी फैक्टर से डिक्रीज करेगा. The impedance in the one circuit is transformed by square of the turn ratio. For example, if the impedance is attached, और मैंने आपको last time हमने impedance भी देखा कि impedance क्या है. Impedance, you can say that it is the total high resistance, the total resistance of the circuit. That is called the impedance. It appears to the primary circuit to have the impedance of Np over Ns whole square. This relation is reciprocal, so the impedance, primary impedance of the primary circuit appear to the secondary. So we have this one. This is a relation that the Ns Np whole square Zp. ये आपकी किसमें रेशियो है? ये इम्पीडेंस है आपकी प्राइमरी की. The next transformer, you have the audio frequency transformer. अब आप जानते हैं कि we have an audio range. आवाज जो है उसकी फ्रीक्वेंसी रेंज करती है from 20 hertz to the 20 kilohertz. So it means you have the different frequency ranges. We have the what? We have the audio frequency transformers work at the frequencies between 20 hertz to the 20 kilohertz and are used in the audio amplifier circuit. They were essential to the wall tube design for the matching the high impedance output of these amplifiers to the low impedance loudspeaker. अब देखें एम्पलीफायर जो है उनकी जो इम्पीडेंस है वो ग्रेटर रहती है एज कंपेयर टू द लाउड स्पीकर. आमतौर पर हम ऑडियो एम्पलीफायर यूज करते हैं. मतलब लाउड स्पीकर जो है वो ऑडियो उनके पीछे एक एम्पलीफायर लगा हुआ है जो कि आपकी आवाज को एम्पलीफाई करता है. और हमारा जो एम्पलीफायर सर्किट है दैट इज एक्चुअली हाई इम्पीडेंस whereas the loudspeaker has low impedance. ज़ाहिर इनकी दोनों की फ्रीक्वेंसी को मैच किया जाता है. So we have a match less need for transformers. Some common arrangement of the audio transformer winding are shown in the figure below. These are the sum of the arrangements जिसमें आप ऑडियो ट्रांसफार्मर्स को अरेंज करते हो. Here the fig A is what? In the fig A what you see have the secondary coil is divided into the two secondary windings. This is called what? और आप खुद देख रहे हैं कि आपका this is a center tap transformer. It means कि आपका जो सेंटर पॉइंट है वो सेंटर पर है. अगर लेट मी से हियर कि here we have a voltage across the primary, so then that voltage is equally divided across the secondary. बस अगर आपके पास लेट मी से कि ये आपका एक स्टेप डाउन ट्रांसफार्मर है. अगर यहाँ पे मैं इनपुट पर 100 वोल्ट अप्लाई करता हूँ तो आउटपुट पे लेट आई से कि 10 वोल्ट मिलता है. और वो 10 वोल्ट जो है वो A और CT के दरमियान 5 वोल्ट होगा और CT और B के दरमियान भी 5 वोल्ट होगा. दिस इज अ सेंटर टैप ट्रांसफार्मर. Here the two dots are here. What the dots actually represent? The dots here represent that the both input signal and the output signal are in phase. इसका मतलब ये हुआ कि अगर आपका यहाँ पर इनपुट सिग्नल जो है वो इंक्रीजिंग है तो आउटपुट सिग्नल भी इंक्रीजिंग होगा. लेकिन इन द केस ऑफ द सेकेंडरी ट्रांसफार्मर वी विल सी दैट कि इन दोनों सेकेंडरी कॉइल्स के अक्रॉस जो आपका आउटपुट सिग्नल होगा दैट विल बी आउट ऑफ फेज. द नेक्स्ट वी हैव द आइसोलेशन. mean ideal transformer. In the case of the ideal transformer, what we have seen is the number of turns in both transformers are same. So it means the turn ratio is 1:1. This is the impedance matching transformer. That is a step down. इसका मतलब ये हुआ कि इन दोनों की ट्रांसफार्मर की इम्पीडेंस जो है वो मैच करेगी. Audio transformers perform the several functions. Number one, when used, they are allow the AC audio signal to reach the loudspeaker whistle, preventing any DC from the amplifier affecting the operation of the loudspeaker. Number two, they provide an isolated external connection for the loudspeaker, improving steadily, and then they can match the low impedance to the loudspeaker to the much higher output impedance of the amplifier. along the maximum power to be transmitted. We have the radio frequency transformers. Frequency transformer actually describe those used at the frequency including RF, radio frequency, VHF, very high frequency, UHF, ultra high frequency. At each of these frequencies, construction varies considerably. First, we have the RF transformers. This is the RF transformer. The RF transformer is considered to be the lowest band of frequency in this group and transform working at the frequencies between the 30 kilohertz to the 30 megahertz. May have their winding turned on the particular frequency for the addition of the small capacitor in one winding as shown in the figure. Here what you see, here we see that this is the RF transformer and here the transformer is connected, in this capacitor is connected and this is a ferrite core. This form a parallel LC resonant circuit with the loudspeaker with the transformer primary and therefore have high impedance at one particular frequency. अब देखें resonant frequency क्या होती है? Resonant frequency mean the frequency at which both capacitive reactance and inductive reactance they are equal. और जब आपकी कैपेसिटिव और इंडक्टिव रिएक्टेंस दोनों बराबर होंगी तो then you can say that the frequency is equal to 1/2 pi LC under root. ये फॉर्मूला ऑलरेडी आपने पढ़ा होगा. The induction of such transformer is often made adjustable and the whole assembly housed inside a metal screening can. The resonant frequency of the circuit can then be tuned after assembly. One adjustable during manufacture is normally intended that further adjustment should not be needed. यानी जब आप इस ट्रांसफार्मर को बनाते हैं, मैन्युफैक्चर करते हैं तो उसमें एक ही दफ़ा इसकी जो इंडक्टेंस है वो सेट कर दी जाती है. तो अगर आप दोबारा इसको चेंज करना चाहें तो नहीं कर सकते. Now we have the other transformer, that is the VHF, that works between the 30 megahertz to the 300 megahertz. Its induction needed in the winding of the transformer is very small and can be achieved by just a few turns of wire. Then we have the UHF, which works between the 300 megahertz to the 3 gigahertz. The losses in the iron or the ferrite cores are too great for these conventional cores to be used. So the amount of the inductance needed can be provided by just a few turns of wire or less. Then we have the power transformers. The power transformers is one kind of transformer that is used to transfer electrical energy in one part of the electrical or electronic circuit between the generator and the distribution primary circuit. These transformers are used in the distribution systems to interface, set up, step up and step down voltages. The common type of the power transformer is a liquid immersed and its lifespan of these transformers is around 30 years. आमतौर पे आपके घरों के बाहर जो ट्रांसफार्मर्स लगे हुए हैं, they are the power transformers और ये ट्रांसफार्मर जो हैं they are dipped in some liquid और इनकी जो एज है वो कहते हैं तकरीबन 30 years की है. Power transformers can be classified into 3 types and based on the range. They are small power transformer, medium power transformer, and the large power transformer. In the case of the small power transformer, can from 500 to the 7500 kilowatt ampere, जबकि मीडियम रेंज जो है वो आपकी फ्रॉम द 100 मेगावाट एम्पियर है, और इससे ज्यादा जो रेंज ऑफ द लार्ज पावर ट्रांसफार्मर कैन बी रेंज फ्रॉम द 100 मेगावाट एम्पियर एंड बियॉन्ड.
सर एक्सक्यूज मी,
Power
वोल्ट एम्पियर का
transformer
मतलब
is a
वाट है ना?
static machine used for the
सर
transforming power from one
सर एक्सक्यूज मी सर.
circuit to the other circuit without changing the frequency. This is a very basic
सर
definition of the transformer. Since there is no rotating and moving part, so a transformer is static. Transformer operates on the AC supply. A transformer works on the principle of the mutual induction also. So this is the power transformers. Okay, so this is the end of the chapter. If you look on your book,